This is example 3.7, which is available on page 74 in your textbook. So in this problem you can see we have a container that is closed. It has oil in the bottom of the container, and at level 2 is the top of the oil, and then above it has air at a certain pressure. They've given us a specific gravity of oil, 0.8. Then we have a series of manometer tubes with oil in the first section, and then beyond that there's air going in the upper tube, and then in the part that sweeps downwards we've got mercury ending at point number 1. So we've got a height of the mercury, which is an indicator of the level of the oil in the system. So in this problem we asked, what is the pressure of the air in the tank? If L1, which is the height that's given there between the level of point 1 and the top of the column of oil, is 400 millimeters. L2, from that same point down to the bottom, the first height of mercury, L2 is 1000 millimeters, or 1 meter. And L3, which is the height from that lowest point to the highest point of the mercury at point 1, and that is 800 millimeters. We're also told in this problem to neglect the pressure changes in the column of air. So in other words, what that means is the air in the system, we're not considering any head difference due to the weight of the air in the pipe, because it's a very short distance and the air is very light. But we are considering the change in head for the mercury and for the oil. Alright, so what we have to do first of all is to work out the properties of the various fluids in the system. We have the oil. First of all, gamma of oil is specific gravity times the specific weight of water, which is 9810, times 0.8 will give us 7850 newtons per cubic meter. Mercury we look up on a table, in our textbook A4 is the table, and that gives us 133,000 newtons per cubic meter. Alright, so we start with this problem by stating the manometer equation. And in manometer equation we're applying between point 1 and 2. So if we look at our diagram again, we've got point 1 in the tank at the oil level, and then we've got point 2 in the pipe, the mercury level. So we're applying the manometer equation. Now the manometer equation goes like this. P1, which is the pressure at 1, plus the sum in the downwards direction of all the heads, so it's gamma I, H, I, all the heads in the downward direction, and then minus the sum of all the heads of fluids in HI in the upward direction, and that will equal to P2. Right, so the pressure at 2 is equal to the pressure at 1 plus the downward heads from that position minus the upward heads from that position. But we also know that P1 is equal to 0. P1, so that's at the point number 1 above the mercury, because that is open to atmosphere, and we're using that atmospheric pressure as a reference. So we're working in relative pressure here, we're not working in absolute pressure. It's relative pressure. So if we assume that is 0, that is our reference point. So let's use this equation and fill in some information here. So we have P1 plus gamma Hg L3 minus gamma air L2 plus gamma oil L1 is equal to P2. So that is looking at the diagram, looking at all the downward and all the upward heads. So we can see from this equation, or from the diagram, moving from the left to the right, all the downward heads and all the upward heads give us that equation. And now it's a matter of filling in the gaps. So we know that P1 is equal to 0 because that is our reference. So that's plus gamma of Hg is 133,000. I stated at the beginning of the problem. We multiply that by 0.8 meters, that's the length 3. L3 is given to us as 0.8 minus 0, because we know that we're not considering any head due to the height of the air column. We're neglecting that, so that's 0, and then then we've got the oil, which is 7850 gamma of the oil times the length of the column of oil is 0.4 is equal to P2. Okay, 0.4 is the oil. Okay, so you can see on the diagram. Alright, so if we calculate that out, we get P2 is equal to the pressure of the air. That's what we're trying to calculate. That will give us a value of 109.54 kilopascals gauge pressure. Alright. So that is the solution. In the textbook they say it's rounded off to 110 kilopascals. And that's the end of this example.